All right, let's take a look really quick at 1.6. Lesson 1.6 is about exponential functions. Right. There are two types of exponential functions. There are growth functions and there are decay functions. Okay, exponential growth and exponential decay. A growth function looks like 4 to the x, where this number has to be bigger than 1. A decay function looks like 1 over 4 to the x, okay, where this number is between 0 and 1. A growth graph would look like it grows from left to right, and it never really touches this axis, but it does get really close to it. Right, so it never will touch it, but it will get really close to it. Okay, growing from left to right. A decay function would look the opposite. Okay, where it starts high and it gets smaller and closer, never really touching the x-axis. Okay. One key feature about exponential graphs is that they will always have the point 0, 1, which is right here. Okay. Now this one it will be 0, 1 right there. Right. Taking a look at the first kind of question that we will look at in exponential growth and exponential decay problems, we will see something that asks for writing recursive rules for exponential functions. So recursive rules for exponential functions. Okay, functions. Okay. Let's say, for example, that the function that they give us is 4 times 3 to the x. Okay. If we were to write this as a recursive rule, we just need to fill in a couple of blanks. The first blank that we fill in is the 4 goes into the first blank. Okay? Because if we plug in 0 for x, 3 to the 0 is 1, and 4 times 1 would be 4. So the initial value is 4. Any number after that is going to be multiplied by this number. So we're going to say that 3 times the number before it. This right here is saying the number before it. So we'll say 3 times the number before it, based on us having a 3 right here. Let's take a look at a question that looks something like this. And it's asking us to determine if it is growth or decay, as well as rewriting the way that it is right now. Okay, so that is t over 4. Okay, t over 4. We could rewrite this as 100 times 0.96 to the 1/4 times t, because 1 over 4 times t is t over 4. Okay, we need to put this in a calculator and see what 0.96 to the 1/4 is. Okay, 0.94 to the 1/4 is approximately 0.99. Okay, so this is how we would rewrite our function. The next thing we need to determine is this exponential growth or exponential decay? The way to determine if it's exponential growth or exponential decay is to see, is this number less than 1 or greater than 1? In this case, 0.99 is less than 1, so we say that it's exponential decay. We also need to see how much is it decaying by. right? So let's find what is 1 minus 0.99, and that is 0.01. How do we change 0.01 to a percentage? We have to move the decimal spot 2 to the right. We get 1%. So the answer is that it's decaying by 1%. All right, let's take a look at the next question. Similarly to the last one, we will use the same numbers, except here we will say 10t. Instead of t over 4, we will use 10t, right? Before we said that 1 over 4 times t is equal to t over 4, right? That's how we were able to separate the last one. In this question, we see 10t, so this is the same thing as 10 times t, and we will be able to separate this question like that. So let's say that 100 times 0.96 to the 10 to the t, right? Because 10 times t is 10t, right? So now we need to figure out what is 0.96 to the 10. .96 to the 10 is about 0.66, so 100 to the 0.66 to the t, right? So this is how you would rewrite this. And we now need to determine, is this number less than 1 or greater than 1? 0.66 is less than 1, so we say that it's exponential decay. Okay. We also need to determine how much is it less than 1 by. So 1 minus 0.66 is 0.34. To make this into a percentage, we got to move the decimal 2 spots to the right and put a percent sign. Okay, so the answer is that it's decaying by 34%. Okay, let's take a look at the next question. Okay, in the next question, we will see something like 71 to the 1.1 times 1.1 to the t minus 3. Okay. Right away, I will tell you to say that instead of writing it as t minus 3, let's say that it is t to the t plus negative 3. Okay. The rule that allows us to add exponents is when we multiply the base and the exponent attached to it. So 71 times 1.1 to the t times 1.1 to the negative 3. Okay. The rule that allows us to add exponents is the rule that says that we can multiply the bases with the exponents attached. Okay, just like this. 1.1 to the negative 3, we see that there's a negative exponent on this, so we need to rewrite that. Okay, this becomes 1 over 1.1 to the positive 3. Okay, to figure out what 1.1 to the positive 3 is, let's put that into our calculator. 1.1 to the positive 3 is 1.331. Okay, so we have 71 times 1.1 to the t times 1.331. Okay, we now need to multiply this number and this number. So 71 times 1.331 is 94.501. And we can put the 1.1 to the t attached to it. Okay, this is how we would rewrite this. Okay, now we need to see, is this number in the parentheses greater than 1 or less than 1? It is greater than 1 because it's 1.1, so we say that it's exponential growth. Okay, how much is it growing by? Let's do 1.1 minus 1, which is 0.1. 1.1 minus 1 is 0.1. And then to make that a percentage, we got to move it 2 spots to the right, so 10%. Okay, so it's growing by 10%. Okay, let's take a look at the last question. All right. Let's say that we had 25 times 1.4 to the t plus 2. Okay. The rule that allows us to add exponents is when we split up the base. So it would look like 25 times 1.4 to the t times 1.4 to the 2. Okay, we've got to figure out 1.4 to the 2 is. 1.4 squared, 1.4 to the power of 2 is 1.96. So what we have is 25 times 1.4 to the t times 1.96. Finally, we got to multiply this number to this number, and 25 times 1.96 is 49. Times 1.4 to the t. Okay. Now we got to determine, is this number inside the parentheses greater than 1 or less than 1? It's greater than 1 because it's 1.4, so we say that it's exponential growth. And how much is it growing by? We do 1.4 minus 1, which is 0.4. To put this as a percentage, we got to move the decimal 2 spots to the right, put a 0, and it would be 40%.